Hello and welcome. Right now, as you watch this broadcast, the interstellar comet 3I Atlas is rapidly approaching its point of closest encounter with Earth. But this is not a routine astronomical event of the kind we observe several times a year. Over the past 48 hours, this comet has begun behaving in ways that have prompted leading astrophysicists on 3 continents to convene emergency sessions, trying to understand exactly what is happening. Last night, the object's brightness suddenly increased by a factor of 40 times in a single night. A comet that could only be seen through professional telescopes has transformed into a brilliant object accessible to advanced amateur astronomers. This should not have happened. Our models predicted gradual dimming as it receded from the Sun, but instead, 3II Atlas is flaring up as if someone flipped a switch inside it. And the brightness is only the beginning of the anomalies. Several hours ago, the Hubble Space Telescope completed a series of high-resolution images of the object, and when those images were processed, they triggered what can only be described as a state of controlled alarm within the scientific community. What we are seeing violates fundamental laws of cometary physics. 3I Atlas has a structure pointing directly at the Sun, not away from the Sun, like all comets, but toward it. Imagine a spear 12,000 kilometers long, aimed at the heart of our star, and this spear maintains its orientation with a stability that cannot be explained by solar radiation pressure, solar wind, or any processes known to us. Let me repeat this, because the significance of this moment is difficult to overstate. Cometary tails always point away from the Sun. This is basic physics that we have understood for over a century. The stream of particles and photons from our star pushes gas and dust away, creating the characteristic tail. But 3I Atlas is doing the exact opposite. Data from Hubble's Wide Field Camera 3 shows an elongated structure with a length-to-width ratio of 8:1. Spectral analysis has revealed the presence of standard molecular fragments like CN, C2, and OH radicals, but also detected lines of ionized metals and what researchers call a non-thermal continuum, light emitted by a process that is neither simple thermal radiation nor fluorescence. In other words, this object is glowing in a way we cannot explain. The comet is currently crossing the constellation Virgo at velocities that unmistakably indicate its interstellar origin. It is not gravitationally bound to our Sun, and after passing perihelion, will leave the solar system forever. But before that happens, 3I Atlas will pass in close proximity to Earth, and the entire astronomical world has trained every available instrument on it. This is a story unfolding right now, in real time. Data is coming in every hour, and each new block of information only deepens the mystery. If you have not yet subscribed to the channel, do so now, because we will be covering every important moment of this unprecedented event. What we are observing may be a scientific puzzle that comes along once in a generation. This contradicts everything we previously thought about how interstellar comets should behave. When an icy body from another star system enters ours, we expect it to sublimate in a predictable fashion, releasing gas and dust that forms a diffuse cloud around the nucleus and a tail shaped by solar forces. But the data from 3I Atlas suggests we are not looking at a passive object responding to the Sun's influence. We may be looking at an active system, one that is channeling energy or matter in a directed manner. And this is where the swarm hypothesis enters the picture. Professor Avi Loeb, who directs the Galileo project at Harvard and has never shied from unconventional explanations when the data demands them, released a preliminary analysis late last night proposing that 3I Atlas may not be a single coherent body. Instead, Loeb and his colleagues suggest we could be observing a cluster of smaller objects, potentially hundreds or even thousands of them, flying in tight formation and collectively producing the elongated optical signature. Imagine a swarm of macroscopic particles, each perhaps a few meters to a few tens of meters across, separated by distances small enough that from our vantage point 2 astronomical units away, they blend into a unified linear structure. If such a swarm were held together by mutual gravitational attraction, or by electromagnetic forces, or by some form of active coordination, it could explain both the anomalous brightness, because the total surface area would vastly exceed that of a single nucleus, and the rigid anti-tail geometry if the swarm were oriented such that its long axis happened to point toward the sun. But here is where the hypothesis becomes even more intriguing and more unsettling. Data from the European Space Agency's JUICE probe, currently en route to Jupiter, but positioned at a uniquely oblique angle relative to Earth and 3I Atlas, revealed something that Hubble, observing along a more direct line of sight, could not fully resolve. JUICE's instruments detected a secondary tail structure, fainter and offset from the primary antitail by roughly 18 degrees, creating what analysts are now calling a double tail or bifurcated emission pattern. This geometry is unprecedented. No known cometary outgassing model, no dust dynamics simulation, no solar-wind interaction scenario produces a stable double tail with that angular separation and that degree of symmetry. So, what does this actually mean? If we take the swarm hypothesis seriously, the double tail might represent two distinct populations of particles within the cluster, perhaps with different compositions, different charge states, or different trajectories. Alternatively, it could indicate that the swarm is not passive but interacting with the solar magnetic field in a complex way, creating current sheets or plasma instabilities that channel outflowing material into discrete streams. Or, and this is the possibility that has military analysts sitting in briefing rooms tonight, the double tail could be the signature of a propulsion system or multiple propulsion systems operating in a coordinated fashion to adjust the trajectory or orientation of the constituent objects. Now, before we go further, let me be absolutely clear. There is no confirmed evidence that 3I Atlas is anything other than a natural astronomical body. No signals have been detected. No artificial structures have been resolved. But the behavior we are witnessing is sufficiently anomalous that we cannot yet rule out explanations that, a month ago, would have been dismissed out of hand. And that brings us to the second major development of the past 48 hours, one that has added a sharp edge of urgency to the scientific puzzle: the sudden, coordinated activation of planetary defense drills by military and space agencies across the globe. On December 6th, the United States Space Force announced that it was advancing Operation Cosmic Sentinel, a large-scale exercise originally scheduled for mid-2026 to this week. The exercise involves tracking high-velocity objects, coordinating intercept calculations with international partners, and testing communication protocols for rapid response scenarios. Within hours, the European Space Agency confirmed that its own Defense Coordination Office was conducting parallel simulations, and Japan's Space Defense Initiative announced it was participating as well. The official explanation is that this is routine, that the drills had been planned for months, that the timing is coincidental. But the language used in the press releases is difficult to ignore. Multiple statements reference scenarios involving objects with non-gravitational acceleration, objects exhibiting unexpected changes in trajectory, objects requiring real-time tracking updates. These are not generic descriptions. These are precise technical phrases that describe, almost verbatim, the behavior of 3I Atlas. The object has shown measurable deviations from a purely gravitational path, small but statistically significant accelerations that cannot be fully explained by outgassing jets alone, especially given the sunward orientation of its primary tail. And the 40-fold brightness increase occurred exactly when solar heating should have been decreasing, suggesting an internal or active energy source. So, we are left with a question that is both reasonable and deeply uncomfortable. Do military space agencies have access to classified observations or analyses that the civilian scientific community does not? Have radar installations, infrared satellites, or other surveillance assets detected something about 3I Atlas that has not been publicly disclosed? Or are they simply reacting, as any prudent defense apparatus would, to an object that is not behaving as it should and that will make its closest approach to Earth in less than 2 weeks? Let me give you the numbers, because numbers ground speculation in reality. 3I Atlas will reach its closest point to Earth on December 19th, just 12 days from now. At that time, it will pass at a distance of approximately 0.15 astronomical units, or roughly 22 million kilometers. That is well beyond the Moon's orbit, far enough that there is no collision risk, no gravitational perturbation, no immediate physical threat. But it is close enough that our best ground-based telescopes and space observatories will have unprecedented resolution, close enough that if there is any fine structure to this object, any surface detail, any modulation in its emissions, we will detect it. And that may be what has defense planners on edge, not the possibility of impact, but the possibility of revelation. If 3I Atlas is a natural object, then the close approach will provide a wealth of data: high-resolution spectra, thermal maps, rotation rates, all of which will help us understand the composition and behavior of interstellar comets and refine our models for future visitors. But if it is not entirely natural, if there is any component of technology or intentionality in its behavior, then the close approach could be the moment when ambiguity collapses into certainty, when what has been whispered in academic backchannels and speculated about in online forums becomes unavoidable fact. And that is a scenario for which there is no established protocol, no contingency plan, no carefully rehearsed public communication strategy. Now, I want to pause here and bring you into this conversation, because this is not a story where the answers are clear or the experts unanimous. We are in real time watching the scientific method unfold under extraordinary pressure, and I want to know what you think. Do you believe that 3I Atlas is an unusually active comet, perhaps with a composition we have simply never encountered before? Or do you think the accumulation of anomalies, the brightness surge, the anti-tail, The double structure, the non-gravitational acceleration, points towards something more? Leave your thoughts in the comments below, engage with each other respectfully, and let's build a community discussion that reflects the seriousness and the wonder of this moment. These are the conversations that matter, and your insights, your questions, your skepticism are all part of how we collectively make sense of the unknown. Let's look closer at the data, because the devil, as always, is in the details, and there are several aspects of the observational record that have not yet been widely reported, but that are circulating among researchers tonight. First, the brightness curve. When you plot the apparent magnitude of 3I Atlas over time, you expect to see a smooth rise as it approaches the Sun, a peak near perihelion, and then a gradual decline as it recedes. What we actually see is a curve that behaved predictably until early December, then spiked upward in a matter of hours, not days, jumping from magnitude 11, which requires a decent amateur telescope to see, to magnitude 7, which is on the edge of naked eye visibility under dark skies. A jump of 4 magnitudes corresponds to a brightness increase of roughly 40 times, and it happened faster than any sublimation model can account for. Sublimation is a thermal process. It depends on the surface temperature of the ice, which in turn depends on solar radiation, which changes gradually as the distance to the Sun changes. You do not get sudden 40-fold increases unless something catastrophic happens, a major fragmentation event, a collision, an internal explosion. But there is no evidence of fragmentation. The Hubble images show a coherent structure, not a debris cloud. So, what triggered the outburst? One hypothesis, proposed by researchers at the European Southern Observatory, is that 3I Atlas rotated such that a previously shadowed region, perhaps rich in highly volatile ices like carbon monoxide or methane, was suddenly exposed to sunlight, triggering a massive, localized sublimation event. That is plausible. It fits the physics, but it requires a very specific geometry and a very specific composition, and it does not explain the anti-tail or the double structure. Another hypothesis, more exotic, is that the object passed through a region of space with a higher than expected density of interplanetary dust or charged particles, and that the interaction between the object's magnetic field, if it has one, and this external medium generated the brightness spike and the unusual tail geometry. But measurements from solar wind monitors and particle detectors aboard spacecraft like Parker's Solar Probe and Solar Orbiter show that the local space environment around 3I Atlas has been quiet. No unusual density fluctuations, no magnetic anomalies. So that hypothesis, while creative, lacks supporting evidence. And then there is the swarm hypothesis, which I want to explore in greater depth because it represents the most serious scientific attempt to reconcile all the anomalies within a single framework. If 3I Atlas is a cluster of objects rather than a monolith, then the brightness increase could result from a change in the configuration of the swarm. Perhaps the objects were initially clumped tightly together, presenting a smaller effective cross-section, and then, as they approached the Sun, thermal stress or outgassing or some internal dynamic caused them to spread apart, increasing the total illuminated surface area. The rigid anti-tail could be the collective outgassing plume from the entire swarm, with each object contributing a small jet that, when combined and viewed from a distance, appears as a single linear feature. The double tail could arise if the swarm has two distinct populations, perhaps a leading group and a trailing group, each with slightly different velocities or compositions, each producing its own plume. This is not wild speculation. This is a testable model. If the swarm hypothesis is correct, then over the coming days, as our observational geometry changes and as the object continues to approach Earth, we should see the linear structure begin to resolve into individual components. We should detect brightness fluctuations consistent with multiple small bodies crossing our line of sight at different times. We should observe variations in the spectroscopic signature as different regions of the swarm enter and exit the field of view. And if we see none of that, if the structure remains coherent and monolithic all the way through the close approach, then the swarm hypothesis fails, and we are back to searching for an explanation. Here is the crucial detail that makes the swarm hypothesis more than just academic theorizing. Professor Loeb and his team ran simulations of what a swarm of objects would look like under different configurations, and they found that if the individual components are between 5 and 20 meters in diameter, and if they are separated by distances of a few hundred meters to a few kilometers, and if they are moving in a tightly synchronized formation, then from our vantage point, the swarm would appear as an elongated, rigid structure with an apparent length of thousands of kilometers. The physics works, the optics work, but the question that immediately arises is, what holds the swarm together? Gravity alone is far too weak at those scales. A 5-meter object has negligible gravitational pull. You would need something else, electromagnetic forces, if the objects are electrically charged, or magnetic forces if they contain ferromagnetic materials and are embedded in a magnetic field. Or, and this is where the conversation becomes uncomfortable, active coordination. If the objects are not passive chunks of rock and ice, but instead are capable of sensing their neighbors and adjusting their positions, then a swarm could maintain its structure indefinitely, across interstellar distances, across variations in solar radiation and gravitational fields. And that is the threshold where natural explanations begin to strain, and where questions about intentionality, about design, about origin become unavoidable. Now let's be very careful here. Science does not traffic in certainty where none exists, and it is essential that we distinguish between what the data shows and what it might imply. The data shows an interstellar object with anomalous brightness, unusual morphology, and behavior that does not fit standard cometary models. The data does not show evidence of artificial signals, of radio transmissions, of optical beacons, of any of the signatures we would expect from a technological artifact. The Search for Extraterrestrial Intelligence Institute, SETI, has been monitoring 3I Atlas across the radio spectrum for weeks, using the Allen Telescope Array and other facilities, and they have detected nothing beyond the natural microwave emissions expected from a cold object sublimating in space. Breakthrough. Listen, the most comprehensive SETI program currently operating has similarly found no evidence of artificial signals. So whatever 3I Atlas is, if it is more than a comet, it is not broadcasting. It is not communicating, at least not in ways we can detect. But absence of evidence is not evidence of absence, and there are many scenarios in which a technological object would remain silent. It could be a probe that completed its mission long ago, and is now inert. It could be a monitoring station that observes but does not interact. It could be an artifact from a civilization that no longer exists, drifting through the galaxy for millions of years. Or it could be entirely natural, and we are simply witnessing a phenomenon we have never encountered before, because interstellar objects are rare and our ability to study them in detail is less than a decade old. This brings us to the implications, and here we must think not just about what 3I Atlas might be, but about what it means for our understanding of the cosmos and our place within it. If the close approach on December 19th confirms that this is a natural object, albeit one with exotic properties, then we will have expanded our knowledge of cometary physics, of interstellar chemistry, of the diversity of planetary building blocks scattered across the galaxy. We will have learned that not all ice behaves the way solar system ice behaves, that the conditions in other stellar nurseries produce materials with different structures, different volatilities, different interactions with radiation. That alone would be a significant scientific achievement, worthy of textbooks and dissertations and refined models of planetary formation. But if the close approach reveals evidence that cannot be reconciled with natural processes, if the swarm resolves into a structured array, if the emissions show patterns inconsistent with random outgassing, if there is any sign, however subtle, of coordination or design, then we are in entirely new territory. We would be forced to confront the reality that we are not alone, that intelligence exists elsewhere, and that it has reached a level of technological sophistication capable of interstellar travel or interstellar communication via physical probes. That would not just be a scientific milestone. That would be a civilizational inflection point. Consider what it would mean. For all of human history, we have wondered whether we are unique, whether the emergence of life and intelligence is a cosmic commonplace or a staggering improbability. We have built telescopes and launched missions and scanned the skies for signals, and we have found nothing. The Fermi paradox, the troubling question of where everyone is, has loomed over the search for extraterrestrial intelligence for decades. If the galaxy is so vast and so old, why have we seen no trace of other civilizations? Why no megastructures, no artificial transmissions, no visitors? One possible answer is that we are indeed alone, that the chain of events required to produce technological intelligence is so unlikely that it has happened only once in our galaxy, or perhaps only a handful of times across the entire observable universe. Another answer is that civilizations inevitably self-destruct before they achieve interstellar capability, that the same technologies that enable star travel also enable annihilation, and that the galaxy is littered with the ruins of societies that did not survive their own ingenuity. But there is a third possibility, one that has always been speculative, but that, in the context of 3I Atlas, suddenly feels uncomfortably plausible. Perhaps they are here. Perhaps they have always been here. Perhaps the galaxy is not empty, but full of watchers, of probes, of quiet intelligences that observe without revealing themselves, that study without interfering. If that is the case, then our civilization has existed under a kind of cosmic quarantine, noticed but not contacted, monitored but not engaged. And if 3I Atlas is part of that network, if it is a probe sent to observe a particular region of the galaxy and we happen to be in its path, then the close approach could be the moment when the observation becomes mutual, when they realize we have noticed them. Now, I want to emphasize again that this is speculation. It is a scenario consistent with the data we have, but it is not the only scenario, and it is not the most probable scenario by conventional standards. The burden of proof for extraordinary claims is rightly high, and the scientific community will demand extraordinary evidence before accepting that 3I Atlas is anything other than a natural interstellar comet. But the reason we are having this conversation tonight, the reason that military drills are underway, and that astronomers are debating late into the night, is that the evidence we do have is not easily explained, and the conventional narratives are fraying. When an object brightens 40 times more than predicted, when it displays a tail aimed at the sun, when it exhibits non-gravitational acceleration, when it shows a double structure that no model anticipated, we are obligated to consider all possibilities, even the uncomfortable ones. That is not sensationalism. That is science. Let's talk about what happens next, because the timeline is compressed and the stakes are high. Over the next 12 days, every major observatory on Earth and in orbit will be tracking 3I Atlas continuously. Hubble will acquire additional imaging sequences, looking for any changes in morphology or brightness. The James Webb Space Telescope, with its unparalleled infrared sensitivity, will map the thermal emission from the object, searching for hot spots or temperature gradients that could indicate active vents or internal heat sources. Ground-based telescopes in Chile, Hawaii, and the Canary Islands will conduct high-resolution spectroscopy, measuring the composition of the outgassing material and looking for molecules that should not be there, synthetic compounds, isotopic ratios inconsistent with natural nucleosynthesis, any chemical fingerprint of artificiality. Radio telescopes will continue to listen, scanning across wide frequency bands for any modulation, any pulse, any pattern that stands out against the background noise of the cosmos. And radar installations, including NASA's Goldstone Deep Space Network and the Arecibo successor facilities, will attempt to bounce signals off the object, measuring its size, shape, and surface texture with far greater precision than optical methods allow. If 3I Atlas is a single coherent body, radar will reveal it. If it is a swarm, radar will show the individual components. And if it is something else, something with internal structure or cavities or organized surfaces, radar will detect that too. The close approach on December 19th will be the climax of this observational campaign. At its nearest point, 3I Atlas will be close enough that even mid-sized telescopes will resolve it as more than a point of light. Amateur astronomers, equipped with CCDs and spectrographs and photometric software, will contribute data alongside the professionals, creating a distributed global observation network that no single object has ever been subjected to before. And in the hours and days following the close approach, as the data is processed and analyzed and debated, we will begin to get answers. Not all the answers, perhaps. Not immediately. Science is a process, and complex questions require time to resolve. But we will know more. We will know whether the swarm hypothesis holds up. We will know whether the brightness spike was a one-time event or the beginning of a pattern. We will know whether the anti-tail persists or dissipates. We will know whether there is any evidence, however tentative, that 3I Atlas is more than it seems. And here is where I want to bring this full circle, because regardless of what we discover, the mere fact that we are asking these questions, that we are taking them seriously, that we are mobilizing resources and expertise on a global scale, tells us something important about where we are as a species. 50 years ago, the idea of interstellar objects was purely theoretical. We had no way to detect them, no instruments capable of tracking something moving at tens of kilometers per second through the solar system. 20 years ago, we could detect them, but we lacked the resolution to study them in detail. 10 years ago, we had the technology but had never actually seen one. And now, in the span of just 8 years, we have observed 3 confirmed interstellar visitors, each one stranger than the last, each one challenging our assumptions and pushing the boundaries of what we thought was possible. We are living in the early days of interstellar astronomy, and the data we gather now, the methods we develop, the questions we learn to ask, will shape how humanity engages with the cosmos for generations to come. That is why this story matters, not just because of what 3I Atlas might be, but because of what our response to it reveals about our readiness, our curiosity, our willingness to confront the unknown with both rigor and imagination. Before we close, I want to ask you to do something simple but meaningful. If you have found this analysis valuable, if it has given you a clearer understanding of what is happening and why it matters, please take a moment to like this video. It helps the algorithm recognize that serious, in-depth science content has an audience, that there are people who want more than headlines and sound bites, who are willing to engage with complexity and nuance. Every like, every share, every comment sends a signal that this kind of journalism, this kind of storytelling, deserves space in the digital landscape. And if you are still watching, thank you. Thank you for your attention, for your patience, for your willingness to sit with uncertainty and to think deeply about questions that do not yet have answers. So, where does this leave us tonight, on the 7th of December, as the world watches an interstellar visitor that refuses to behave? We are in a state of scientific suspense, caught between the familiar and the unprecedented, between natural explanations that feel incomplete and extraordinary hypotheses that feel premature. We have 12 days until the closest approach, 12 days of continuous observation, 12 days of data accumulation and model refinement and debate. And at the end of those 12 days, we will know more. But I suspect, and I say this as someone who has covered breakthrough science for over a decade, that we will also have more questions. Because that is how discovery works. Every answer opens new doors. Every solved mystery reveals deeper ones. And the universe, for all our cleverness and technology, remains vastly more complex than our theories allow. 3I Atlas is teaching us that right now. It is teaching us humility, teaching us that interstellar space is not the sterile void we imagined, that objects from other star systems carry with them the chemistry, the physics, the history of places we have never seen and may never reach. And it is teaching us that when something anomalous arrives, when the data does not fit the models, we must resist the temptation to force it into comfortable categories, and instead let it be what it is, strange and challenging, and worth every ounce of attention we can muster. There is a phrase that scientists use when they encounter something genuinely new, something that resists easy classification. They say it is interesting. And interesting, in the scientific lexicon, is not a casual word. It is not a polite euphemism. It is a recognition that the universe has surprised us, that our understanding is incomplete, that the work ahead will be difficult and uncertain, and absolutely essential. Three-Eye Atlas is interesting. It is interesting in ways that will occupy researchers for years, regardless of whether it turns out to be a comet with exotic ices or a swarm of macroscopic particles or something we do not yet have words for. It is interesting because it arrived from interstellar space, carrying no guarantee that it would behave the way our solar system objects behave. And indeed, it is not behaving that way. And now we must figure out why. And in that process of figuring out, in the observations and the models and the debates and the revisions, we are doing what humans do best. We are learning. We are adapting. We are expanding the map of the known at the expense of the unknown. I will be here every step of the way, bringing you the latest data, the expert interpretations, the conflicting hypotheses, the slow accretion of understanding that defines the scientific method at its best. This is a story that will evolve, and I am committed to evolving with it, to following the evidence wherever it leads, to asking hard questions and insisting on rigorous answers, because that is what you deserve, and that is what the story demands. We are standing at a threshold, and what lies on the other side, whether it is a refined understanding of cometary physics or a revelation that rewrites our place in the cosmos, will depend on the quality of the work done over the next 12 days, the precision of the instruments, the integrity of the analysis, the courage to accept conclusions that challenge our assumptions. So, stay with us. Stay curious. Stay skeptical. And let's see, together, what Three-Eye Atlas has to teach us about the universe and about ourselves. Thank you for watching, and we will see you in the next update as this extraordinary story continues to unfold.